Okay, so in today's lesson, we're going to be talking about horizontal transformations. So we don't always do this very much, but we're going to go over it today just so you have the knowledge of it, and it goes along well with our vertical transformations. So we will determine the effects on the graph of the parent function f of x equals absolute value of x when f of x is replaced by f of bx and f of x minus c. Horizontal compression, we have a couple of vocabulary terms, horizontal compression and horizontal stretch. So with horizontal compression, the function is elongated or narrower than the original function. It's basically compressed from the sides. It's pushed in it's closer to the y-axis. And then horizontal stretch is the function is shrunk or it's wider than the original function and it's stretched out on the sides. It's farther away from the y-axis. Our transformation, our y-axis, we have when we go from f of bx to f of negative bx, that's a y-axis reflection. So we've had x-axis reflections where we reflect across the x-axis, up and down. A y-axis reflection changes the sign of b, moves it across. It goes left and right, so it switches the side to side. Horizontal transformation, when f of x is replaced with f of bx, it changes the slope. So this is when we have a b value inside the absolute value. And so when the absolute value b is greater than 1, it's a horizontal compression. And when the absolute value of b is less than 1, so like 2/3 here and 0.5, it's a horizontal stretch. It's a horizontal stretch. And just so you know, a negative does not mean it has to be a horizontal stretch. So a negative does not mean horizontal stretch. It could be, but it doesn't always mean it. Okay? Translation, we already went over this in our notes from the previous day, but we'll go over it again. Horizontal translation, when f of x is replaced with f of x minus c. So if we look at example x plus 2, x plus 3, we would say translation left. And then when c is less, when it's minus, it's a translation right. And looking at what we did with vertex form and comparing it to this, we can always remember x's lie to us. This is our horizontal transformations are opposite of our vertical transformations. Horizontal transformations are opposite of vertical. Okay, so if we just remember that, it'll be very helpful to us. All right, let's move on to some examples. So first example, determine all transformations on the absolute value parent function. So f of x equals absolute value of 4x. So because it's inside, we know it's a horizontal something, and the number is greater than 1, so it's a horizontal compression. For b, f of x equals absolute value of x plus 7. X has lied to us. It's not moving 7 to the right. It's moving 7 left. And then here's a new one, absolute value of negative x. So the negative sign previously was outside the absolute value, which would flip it over the x-axis, but this is a y-axis reflection. And we'll see one of those a little bit later on here. Okay. F of x replaced by f of bx, where b is equal to 6. The new function is f of x is equal to absolute value of 6x. And that's also a horizontal compression. For whatever reason, it's easier to write in cursive. So hopefully you can still read it. And then b, fx replaced by f of x minus c, where c is negative 6. If we think about it, we have x minus c equals x minus a negative 6, which becomes x plus 6. So f of x equals absolute value of x plus 6, and this is left 6. All right, so there's our first page. Let's flip it over and do some examples.